Financial Maths Geometric Series Type 6 Loans and Mortgages. So basically there are going to be two ways in which we can approach these questions for loans and mortgages, and the method that we're looking at today in this video is using geometric series. In the next class we'll look at method 2, but we have to be careful with this method, and that will be in the second video. And this is going to be using the amortization formula. So we can't use it for all questions, only specific questions. So I will star that. So we have here an example where a couple wants to buy a house and needs to borrow a mortgage of €270,000 over a period of 30 years. They are able to obtain a fixed rate mortgage of 4.25% per annum. So it's not a variable rate where it can change from year to year, but it is a fixed rate mortgage. So that's going to stay at 4.25% per annum for the period of this calculation, which is 30 years. The bank requires them to pay the mortgage back in equal monthly instalments. And we're asked, well, what is this monthly repayment amount? So in other words, our mortgage is the geometric sum of the present values of the monthly repayments. And unless stated otherwise, then it is assumed that the repayments I should say. So assume that the repayments are made at the end of the accounting period. So in this case, because it doesn't state whether the repayment is made at the start or at the end of the month, then we assume it to be made at the end of the month, okay, unless it states otherwise. If it states at the start, then obviously we'll have one of ours to the power of 0. In other words, the first repayment would be to the power of 0. So because we're getting the sum of the present values, then we know we're going to be getting P, our present value, is equal to F over 1 plus I to the power of T. And then we're going to write that as a geometric series. So the first thing I have to note here, however, is that I'm given a fixed rate per annum, and I'm looking for monthly instalments. So that means I need to change my rate before I can start. So P is 100%. F is 100% plus that AER, which is 4.25. So we have 104.25% is going to be 1.0425 as a decimal. And because we're going for monthly, then it's going to be 12 months in a year. So T is going to be 12. So we'll have F equals P by 1 plus I to the power of T. So subbing in our values, we have 1.0425 is equal to 1 by 1 plus I to the power of 12. I get the 12th root of both sides and get I on its own. Then we have I is equal to 0.003474495. So in other words, our monthly rate is equal to 0.3474. So I'm going to keep it correct to 4 decimal places just for the purpose of this example. And again, in the Leaving Cert, they would give you different number of decimal places or significant figures for your rate. So now we know our monthly rate, we need to set up our geometric sum, and our mortgage that we're borrowing is 270,000. So we say our mortgage is 270,000. We've just worked out our new interest rate there for the monthly is 0.3 what did I say, 3474%, so 0.003474. The time that we're borrowing our mortgage for is 30 years, but we have to repay that monthly. So 30 years is going to be 30 times 12 months, which means there's going to be 360 compounding periods. And we want to know, well, what is our amount that we're repaying monthly going to be? So in other words, we have 270,000 is going to equal to the amount, and that first amount that we pay back to the bank will have to be discounted back 1 month, because we are assuming it to have been repaid at the end of the first month, unless told otherwise. The second one will be discounted back 2 months, and so on until we get to the last repayment. The last repayment will have to be discounted back to the present day, 360 months. So this is our first repayment. And we're assuming it's made at the end of the month, unless told otherwise. We're discounting it back 1 month. Okay, so if we take out A as being common then, we're left with our geometric series. So we can see A and OR nice and easily. So A is 1 over 1.003474. OR is also 1 over 1.003474, which means OR is less than 1, and our sum to n terms then is going to be A times 1 minus OR to the power of n over 1 minus OR. And then n is our compounding periods, and we have 360 compounding periods. In other words, where interest is applied. And therefore, that means that there must be 360 terms. So if I sub in, the sum of the first 360 terms is 1 over 1.003474 times 1 minus 1 over 1.003474, and that's to the power of 360, all over 1 minus 1 over 1.003474. So again, being very careful, subbing that into our calculators. So that gives us 205.2554052. So what that means then is my mortgage of 270,000 is going to equal A times 205.2554052. So to get the monthly repayment, I'm going to divide both sides across by my 205.2554052. So that means my monthly repayments for my mortgage is going to be €1,315.43. So in other words, the monthly repayments are going to be €1,315.43. Okay, so in your books, you're going to do the following questions. So 6 and 14, page 264.